Welcome back to an update for the Evo 9 GTA Dad Wagon. So, got the car coming up for another lot of tuning this week. So, since the last video that I made, which was basically from the initial lot of tuning after the ECU got installed, there were certainly a few things that had to be changed and have kind of progressed over time. So I was going to go through some of those map changes, some of the issues that we found, just some of the drivability, and hopefully some of the things that are going to get done this particular time for AFR and ignition. So the primary purpose of the car kind of going in this particular time is all the calipers are going to be getting rebuilt and basically all the brakes are getting overhauled. And also picked up from Benchmark Solutions one of their 18 tooth trigger disc kits. So this is going to get installed. I've heard some pretty good things about this, particularly when it comes to initial cranking. The Evos seem to get a little bit cranky with cam and crank sync with an aftermarket ECU with running the stock sensors. Haltech actually did release a firmware update not too long ago that kind of helped with that. But since these Benchmark Solution trigger wheels basically only work with aftermarket ECUs, I thought it'd be worthwhile getting one of those put on, and yeah, just see how it goes. Likewise, they also do a kit where, since I'm no longer running a MAF, what you're able to do is utilize the signals from the stock airflow meter. So there's basically a bunch of signals on here. This is kind of how it's broken down. So there's like 5 volt, the barometric, the actual mass airflow reading, intake air temperature sensor, and like a sensor ground. So what you're able to do if your airflow meter has been removed and you go into a speed density tune, you can then essentially tap into those signals because they're either an AVI, like an analog signal, or a synchronous pulsed input. With the adapter that Benchmark Solution sells, plug into the AFM wiring harness, and then basically use those signals to run other things in the car. So what I'm getting installed is also a flex fuel sensor, which will use the original sensor ground along with the MAF sensor, or the MAF wiring rather, to basically, it will go back through the vehicle wiring harness and then into a synchronous pulse input on the Haltech. And then you can configure that on the Haltech to basically run a temperature, composition, flex fuel sensor and get all that dialed in. So the initial benefit is going to be able to measure fuel temperature, which then you can map against fuel density. So looking forward to see how that plans out, and inevitably down the road, the goal is still to get the car tuned on E10. So during the expensive weeks here in SA, 98 octane can get up to like $2.20 a litre. So whereas E10, I believe, is still going to give, at least at this particular power level, the same level of performance. May take a small hit to overall consumption and distance from a tank of fuel. However, on the expensive weeks, by comparison to E10, it's like 60 to 70 cents a litre cheaper. And there's been a lot of improvements to the low ethanol content fuel. So that's further down the track. However, get the flex fuel sensor installed, get the trigger disc installed. Yeah, looking forward to seeing what happens. So I'm going to run through basically a few of the times that the car has been back for tuning, and kind of just step through what was changed and kind of the issues that were found. So I just got you guys set up in front of me here so I can kind of just show you what's going on. So when the car was initially tuned, basically just utilised the Heltec base map for, I can't remember if it was an Evo 8 or Evo 9, either way. So basically it utilised the AFR map and the ignition map from the base map provided from Heltec. So the car was run up on the dyno, everything was fairly okay, like there were no massive problems. But this is from the dyno graph that was shown in the earlier videos. This was with this particular tune. So on the dyno graph I pointed out there was a few little low spots, and that was definitely very noticeable while driving. So end up taking the car back to get another lot of tuning done. What was also noticed was it started to pick up a significant amount of knock. So whilst it wasn't particularly prevalent whilst it was getting all the runs done, after actually just driving the vehicle out on the street, the ECU started picking this up. So ended up taking it back. So then to basically get those things done. So on the Nexus, apparently you can dial in the knock control a little better on the old Elite ECUs. So this was still at a time when the Nexus S3 was still fairly fresh, so the guys hadn't had a lot of exposure to a lot of the newer NSP software and the NXS ECUs, but they were able to dial all the knock control back in again and really fine tune it, and I haven't had a bit of knock since. Likewise, what ended up happening, some other issues that were found on the first lot of tuning. So yeah, it started getting quite a bit of knock. There was the flat spots whilst driving. Whilst I wasn't aware of it yet, the O2 control wasn't actually working yet. So whilst you can see it kind of operating down here, that was under very light load, almost idle conditions. Basically the O2 control would go into, I think it was delayed or transient. I think it was, yeah, transient, sorry. And I wouldn't find this out for a little while because I was a bit nervous to just go into the ECU and just try and find things myself. But I'll touch on that a bit later. So yeah, a few little things to figure out after the initial lot of tuning. The base maps, yep, didn't particularly work too well. So this ignition map is has basically been duplicated from the stock ECU, and basically the reason why it knocked over in this particular area here is something to do with trying to basically bring the converter up on the GTAs, I've been told. And if the ignition is a little too aggressive, you'll just get, yeah, as you saw, just an insane amount of knock. So this ignition map is stock and obviously fairly conservative. The AFR table was modified slightly from the first tune. Honestly, there wasn't probably a huge amount of issues here. The figures that are being used here was to try and dial in an initial lot of fuel economy on the vehicle. So that's where you can kind of see some of the more leaner mixtures. And yeah, that was going fairly well. And again, after this Second lot of tuning, all the knock was removed. Yeah, the flat spots had kind of been tuned out and became considerably more drivable on the street. But again, the O2 control still wasn't functioning properly. So you can see it was only pretty much coming on under idle conditions where there was no transit occurring. Transient is utilized for your map prediction. So when transient is active, your O2 control is not active. Again, didn't particularly realize this until a little bit later. So overall for the second tune, still using a modified base map to try and get some economy out of it. However, due to the O2 control not actually being active, it was for the most part never reaching these AFR targets. So we move on to the next lot of tuning that I went in for, and this is now the AFR map from the stock ECU. So it's actually more, take that out. This is basically what the stock AFR map looks like on the stock ECU. So this is basically what it's trying to target. So if you're a GTA owner and you're wondering why your fuel economy is absolute shit, after me driving around for thousands of kilometers and putting absolute hundreds of dollars worth of fuel in this thing to just try and figure out the O2 control issues and just where where it wants to sit at certain cruise conditions, your idle is spastically rich. So basically it'll want to hover at around 800-900 RPM, so between these two figures here. So it's very high 13s, low 14s at idle. So you can cut a lot of fuel out there. Likewise, this particular area in here, as you're accelerating, so up the speed, like from a set of traffic lights, they'll basically want to map through this area here, depending on how aggressive you are through the throttle, on the throttle. So at steady state cruising and you start to accelerate, it'll come through this area here, and it's not unlikely that you'll start dipping into these 12.7s, 11.8s, this area here, if you're basically accelerating up the speed, say like even from 60 to 80 or even 60 to 90k an hour. And yeah, this uses an absolute metric shit ton of fuel. So the big thing for me, what I found was at 110 cruising speed, it pretty much sits on the cusp in here or around this generic area in here, on a flat surface doing 110, and even slight acceleration will start pushing it out into this area here. So there is a lot to be had with modifying this bit of the AFR table and your idle for fuel economy, which we'll get to in a bit later. But just to recap, this is now the stock AFR map from the stock ECU, and obviously we still retained the stock ignition map from the stock ECU. I was kind of hoping that this was going to be done on the initial tune, but again, I kind of put this down to a lot of people really haven't dealt with a lot of GTA tuning in Australia. Like there are certainly a handful, and I mean literally only a handful of people that are probably SMEs or experts in this particular area, but for the wider tuning population, it's not a lot of people have had a lot of exposure to this. So it's been a bit of a learning process for myself and the workshop as well, but overall it's been a fairly positive experience. So yeah, got stock ignition map, stock AFR map, and you could definitely tell that the car drove much like it was on the stock ECU, which all things considered, it had the stock base maps from the stock ECU. Likewise, I still wasn't aware that the O2 control was functioning correctly, which was an absolute pain in the butt. So even then, it was still not trying to reach these AFR targets because the O2 control was just not becoming active. And again, it was due to the transient active turning off the O2 control. So not knowing absolutely diddly squat about tuning for the most part, I tried to do some research into why the map prediction was coming on, why transit was being active and O2 control was not. So that took quite some time to figure out. However, that came down to modifying the transient TPS scaling. So I had to increase this from 300 to 400 percent per second. So that kind of gives you your upper and lower thresholds that if it goes outside of those parameters, and that's when transient becomes active. And the other one that took a little bit of fiddling around was the throttle derivative filter. So this derivative filter being set to 3 milliseconds, that kind of acts like your window of operation. So since it was set so low, again, this is just from the base map, it was continuously active. So pretty much any amount of throttle position deviation would set off the transient filter and basically making transient active, which when looking at the O2 control, the O2 was only ever active at idle. And that's because there was no throttle input. So it took a little while to find a happy medium of the derivative filter along with the actual scaling. So finding out what my window of time was to have the filter active, and then basically the threshold to which it was active. And once I figured that out, all the O2 controls started working pretty well. But yeah, that was weeks and weeks and kilometers of driving to try and figure this stuff out. But certainly learned some pretty cool things. So that solved most of those problems. I've done a few little tweaks here and there to the tune. Nothing probably worthwhile mentioning here. Just trying to again tidy up a little bit of fuel stuff with trying to create some efficiencies. I'm finally starting to get some very consistent economy figures now. However, it has certainly not gone the direction that I wanted it to, just initially. So, pardon me. I originally stated in the first video that on the stock ECU, the car was getting on average about 12 litres per 100. And that was for those particular temperature conditions, and I think the boost when that was brought in may have had something to do with it as well. So all things considered, yeah, that wasn't too bad. With me trying to figure out all the O2 control plus all the other bits and pieces just to try and figure out what I can copy across from the stock ECU, I was unable to get any sort of longevity in the fuel consumption usage, and it was, yeah, certainly all over the place. However, now that everything has been kind of tidied up a little bit, it's hovering around at about 13.5 litres per 100. And part of that is it's now absolutely freaking cold here in SA, and a lot of the air temp corrections come calculated air temperature was a new thing that I found out about. So if the calculated air temperature is higher, you've got more of a reduction in fuel because your air density is less because the air is hotter. Now that the air is getting a lot colder and more dense, it's pulling less and less fuel out because as the temperature gets colder, you need more fuel. So with this particular offset and the calculated air temperature for most days now being between 30, 40 or 50 degrees rather than 50, 60, 70, it's now it's not taking as much fuel out. It's not that it's adding, it's taking less out. However, yeah, getting some fairly good consistency now. At about that 13.5. So, which leads us into the map, or the AFR map that I've kind of built myself to try and take out fuel across the map. So just for reference, trying to target mid-11s up here, which should hopefully on the dyno come out at about 12 to 1, hopefully, in the high end. On the stock fuel map, it generally tries to target like 9.5, 9.3 to 1 air fuel ratio, which is ludicrous on just regular octane pump fuel, to the point where I've been able to do some logging, and even with the injectors, the correct injector sizes set, it also has the injector latencies from the stock ECU at in this like 5,000 RPM range, getting out towards the 17 pound that it's targeted to. When it's trying to target like these 9.5, 9.3 air fuel ratios, it legitimately can't get there. So on all the stock equipment that's on the car, stock fuel pump, injectors, all the rest of it, the timings, the injectors will hit 110% duty cycle and still not be able to get under 10 to 1 air fuel ratio whilst it's trying to target these ratios here. Like, it is so spastically rich in this area, it is absolutely insane. Like, you wouldn't run these air fuel ratios on E85. Like, that is just how rich this thing is. And it can be seen even just driving the vehicle under light load, and then definitely under heavy load, just the amount of fuel that just bellows out the back of this car is monumental. And all things considered, it's a stock AFR map. So I'm very excited this week to get the new AFR map in with all the new targets. So this is the new AFR map compared to the stock AFR map. So this is where wanting to lean out the mixtures. So this is my new proposed map, and then this is the current AFR map, or the stock AFR map that's in the car currently. So the goal here was to try and achieve the same shape to the fuel map, because I think that played a big part in the initial lot of tuning, where it just didn't represent how the car wants to come onto power and just how the gearbox wants to apply power. It seemed very unhappy. So I've tried my best here to kind of duplicate the same overall shape, which hopefully you can get from the colors on the screen here. And just take out a bit of fuel. Now the tricky part was trying to figure out how to actually scale this, because I needed more percentage out up in this area here, and then obviously less and less and less and less as it came down here, and then apply that to the actual shape of the AFR map. So whilst I don't think it's going to be perfect, I hope it is going to be close enough that just need to modify a few cells here and there. But the big thing is, as I mentioned, bringing up the idle air fuel, which I've already done on the car. Like this is already set, and then basically this area in here for basically that high-speed cruising. So that way, whilst I do some long distance driving over Christmas, it's trying to target that 14.7, even mid to high 14s, whilst it's at about 110k an hour under load, while still hoping to achieve enough fuel for cooling as well. So that's my other primary concern. But yeah, super excited to see how this goes, and going to be doing some ignition tuning as well this particular time around. So again, basically asked the workshop to reach out to Benchmark Solutions, because Benny there, I've been told, has done a bit of tuning, and again, one of these handful of people that have had reasonable exposure to GTA tuning, to kind of give a helping hand or a guiding hand to where we can modify some ignition tuning. One, to just hopefully try and create some efficiencies in the combustion, and hopefully try and, with the reduction in fuel and increase in timing, try and pull hopefully some power out of the vehicle as well, just to try and pick it up a little bit, because yeah, I think it's running fairly stock power, like 130-ish kilowatts or 170 horsepower, which is nothing to write home about and gets me to A to B. But yeah, hopefully with a few little tweaks, it'll just be, the pickup will be just a little bit better on the street, just for daily driving duties. And yeah, super keen to work through that. Yeah, so super excited to get the car back. There's certainly been a lot of room for improvement and learning opportunities along this path. I've learnt a lot, just researching everything and trying to have it make sense to me. Likewise, if I have a bit of an understanding and the tuner has a bit of an understanding from their experience, and then hopefully we can try and meet in the middle and try and get the best outcome. So yeah, super excited with what's coming this week. Yeah, super excited to get the new parts on. Yeah, sorry, it's probably been a bit boring. However, this has just kind of been going through the nitty gritty of all the tuning and all the processes over the last maybe 5 to 7 months or so at this point in time. And yeah, super excited to see how we go with all the fuel economy tuning moving forward. So yeah, stay posted. I'll probably do another video once all the tuning's complete, hopefully at the end of this week. Show you all the new rebuilt calipers, because those are getting new seals, getting repainted, new stickers, and yeah, the new flex fuel sensor as well. So lots of cool things coming. Stay tuned, and hope to see you in the next video, you legends. Bye for now.